Good evening and welcome to the AWS Canberra User Group for November 2021. Before we begin, we'd like to start by acknowledging the traditional custodians of the land we present from, the Ngunnawal people, and acknowledge their elders past and present. This month, we've got a pretty familiar looking agenda for you. We've got what's new in AWS this month, a bunch of white paper releases, and then our main talk tonight will be on unit testing CDK projects, a deep dive with our very own, very handsome Brian Farnhill. Before we get into it though, check us out on YouTube. So if you're looking for any of our previous shows, there's a URL. Go along, please subscribe. We're looking to get to that magic number so that we can get our own nice fancy URL. Please do so. All the old content's there. And yeah, look forward to hearing your comments on those too. So in terms of what's new for this month, 209 new features or releases this month so far. We've still got the best part of a week to go, so it'll be a heap more. Now, what that looks like in our usual graph, you can see a really big uptick in releases this month from the previous few, with reInvent just around the corner. That's why we're sort of getting that big surge. And when it comes to what's new, both Brian and I like to call this part of the year pre-invent. It's all the exciting rush of releases that we get just prior to the big reInvent. And when it comes to the new releases this month, we've got a few more than we normally do. I'll try and get through them at a reasonable clip for you, but I almost guarantee I have failed to include your favourite release of the month because there's just so many. So please go back and have a look. It's been an amazing month for releases. Have a look, see what's there, and I'm sure you'll find something that's valid to what you're doing today. So to start with, you'll notice that we've got no service icons for these. They've only just come out, a couple of new services. The first of those is the general availability of Aws Resilience Hub. So what this is a new service that allows you to monitor the resiliency of your applications in AWS. So resilience of applications measured in like RTOs and RPOs. It helps you assess what your application, how resilient it is, but it also provides actionable insights and also integrates with other services such as our fault injection simulator. And it also has APIs for developers to start being able to assess their resilience during their pipeline builds. So it's a really, really interesting way to start getting a view on how resilient your application is. The other new service released this month is the AWS Elastic Disaster Recovery Service. So this is the go-to service for doing disaster recovery of your existing capability out to AWS. It's built on top of Cloud Endure technology. It supports migration of key workloads such as Oracle and Microsoft SQL databases, your virtual servers, and it gives you a consistent environment to do things like fire drills, failover, failback, and all of those things. Really, really good way to take advantage of the elasticity of cloud to provide those disaster recovery services while using a bare minimum of infrastructure in the meantime. In our compute land, so the first one for this month is a preview of Amazon Linux 2022. The reason I wanted to bring this up is much more around the supportability. So you'll get, as of Amazon Linux 2022, you'll get a new release every 2 years with an additional 3 years of maintenance after that. Coming up to a much more predictable release cadence. And it also has the ability to lock into a consistent package. So you choose when to take patches from that. It's based on Fedora for those that care. The general availability of G5 instances. So we've got a couple of new instance types this month. G5s are our new graphically intense instance types powered by NVIDIA. Performance than the previous G4DN instances. So if training machine learning models or graphically intensive applications is what you're doing today in AWS, absolutely worth having a look at these. We've also got the new R6i instances, and now these are our memory optimized instances. These ones are, again, about 15% more performant than the previous generation, and they also have 2 new instance sizes that'll take them up to 128 virtual CPUs and 1,024 gigabytes of RAM. So significant amount of infrastructure that you can scale up to there. Lastly, we've had a few services this month that have released support for Graviton 2 processes. So Graviton 2 processes sort of give you 40% more cost performance benefits. So in this case, Fargate, so your containerized workloads now got significant cost savings by being able to run on our new Graviton 2 processes. Well worth checking out if you're running containers on ECS today in Fargate. From some of the other services this month. So we've got some really long-winded names of releases this month, so I won't drain all of them. This first one around Fleet Manager, though, it provides single-click access to a Windows desktop integrating with AWS SSO or Okta or Ping, whatever your identity provider is, so that you can get access to a Windows desktop through the AWS console, integrating with your existing identity providers. Really, really great way to make life a little bit easier for you in the console and provide that level of auditability as that as well. AppStream 2.0 releases Elastic Fleets. This is a serverless fleet type, so for applications that aren't used regularly, this is a great way of providing on-demand access to these applications in a way where you don't have to worry about the overhead of managing fleets and scaling policies and all of those things. You can just use them on demand as users require it. So great for things like demonstration environments or training exercises where you only need something temporarily. Lastly, in this page, the capability to switch license types for Windows Server and SQL Server applications on EC2. So this integrates with our AWS License Manager service. There's a few moving parts to this behind the scenes, but have a look. If you need the ability to be able to manage where your licenses are allocated in EC2 Windows or SQL Server, it can be really, really useful. Next, SageMaker launches a fully managed RStudio workbench. So RStudio is, this is an industry-first fully managed RStudio IDE integrated with SageMaker. If machine learning and those sorts of analysis is your cup of tea, this is absolutely worth a look. CI/CD configuration, this one is about SAM pipelines. So we've talked about this in a previous user group event. It's now generally available and it comes with templates for all your favorite CI/CD systems and allows you to provide consistent pipelines for your serverless applications. And lastly, a bunch of our toolkits using the Cloud Control API have now got interaction with over 200 new resource types. So the ideas you can see there, Cloud9, JetBrains, VS Code, you can now explore from that a much larger number of resources than you could before, and there'll be many, many more coming as well. So this page is some of the little things that have been released this month that are perhaps not great at first glance, like they're not massive like a big new service, but these things do make life a lot easier. The first one of those is some improvements in the navigation bar of AWS Management Console. So what this allows you to do is once you start setting favorites and do stuff, it's a new layout, much nicer to use, much easier way to prioritize that. But also while you're there, if you notice when you start searching for things in the AWS Management Console now, it will also link out to things like blogs, documentation. So it's a quick way to find other information that might be useful to you as well. This next one's got to be one of my favourites. As someone who used to work in an operational environment a lot, IAM now makes it more efficient to troubleshoot errors. So what this actually manifests as, if you're a developer trying to do something and you get an access denied error, it will tell you that a service control policy blocked you or an IAM policy blocked you. It's just a much better way to help people start troubleshooting what these errors are. Absolutely a great release, even if a minor one. And AWS Control Tower now supports nested organizational units. So for those of you who are running, say, a cloud platform engineering team, your accounts and your organizations can now be put in a more hierarchical view, allowing you a way to manage policies for groups of accounts at a more centralized point. Worth noting, we've still got a customizations release to go before we get full support of the guardrails, but this is an excellent starting point. The next one is very close to my heart because it's built by my team at AWS Professional, or by the team I work in at AWS Professional Services. So the Cloud Adoption Framework 3.0 is now available. So the CAF, as we call it, it provides a a lot of guidance on how to build your cloud transformation journey and the sorts of things you need to take into account when doing so. There's a whole bunch of stuff to unpack in the CAF. Really, really great way to help think about how you're going to do your cloud transformation. Absolutely worth diving into that if you're embarking or you're at any stage on your cloud journey. This will have absolutely useful, practical information to help you guide that journey. In terms of where to get it, that's a great segue into our white papers for the month. So the first of those is an overview of the CAF. So this has been updated for the CAF version 3. If you go to aws.amazon.com/whitepapers, you can absolutely get your hands on that, and that will get you started on the CAF and all the benefits that brings. 37 white papers in total this month though. So a massive amount of content. I only cherry picked a select few here. Some of those are updates, as you can see. So the microservices one has things like adding Event Bridge and some of our managed services around Grafana and Prometheus. And the best practices for data and analytics applications. For those of you running data lakes, this is about how to best make use of things like S3 and Glacier, and anyone who's building a data lake on that S3 thing will absolutely get some value out of this update. Next, our well-architected framework has a number of lenses. A new one of those is the management and governance lens. So for those of you looking at your control tower environments we were talking about before, and some of that centralized governance, this is well worth a read and helps aggregate a bunch of the best practices from what we've seen working with our customers. And lastly, some guidance on establishing your cloud foundations. So this is very much around that core part of your cloud environment and what capabilities you need to build out to build a well-architected foundations for your cloud workloads. In a few days, we have reInvent. So definitely, like a lot of content here will be online. Register. Worth calling out here that Peter DeSantis's keynote is in a friendly time zone for us here in Canberra. It's around 10 o'clock in the morning. I think it's on Wednesday or Thursday. Well worth tuning in and having a look if that's a cup of tea, but everything else will be available later via live stream. As I said, this is our premier education event, so well worth tuning into for some really great deep technical content and really where you can learn some great stuff about our services. And with that, I will hand over to the amazing Brian Farnhill, who's going to take us through the main talk for the evening. Thanks, Brian.
Good evening, everyone. Hi, I'm Brian, and tonight I'm going to take you through a bit of a deep dive into unit testing for the AWS CDK. So for those of you who haven't met me, I am a DevOps specialist solutions architect at AWS. I've been working here for about 4 years now. And the CDK is quite possibly one of my favorite things. So I'm genuinely excited to be able to rock up and give this talk to you guys tonight. So what am I going to be taking you through? We're going to start off with a little bit around what is unit testing and why do we care. We'll talk through why unit testing in the CDK is important and sort of what some of the mechanisms are for doing that. We're going to go into a little bit around how do we build and model our infrastructure for testability. We're going to go through how we can view and interpret test results in different contexts. And I'm going to introduce you to a bunch of the different testing patterns and ways we can look for specific object structures in our code and what that looks like when we start writing unit tests. So to kick things off and set a bit of a frame here of what is unit testing and why do we need to do it. So unit testing we define as a software testing method by which individual units of source code, so sets of one or more computer program modules with associated control data, usage procedures, and operating procedures, are tested to determine if they are fit for use. So if we park the dictionary definition and pick out the bits that are interesting, we come to a couple of pieces here. The individual units of source code and testing those, and figuring out what's fit for use. So really, in terms of infrastructure as code and what the CDK brings to us, we're dealing with some actual source code. You know, we're not in YAML templates or JSON text files anymore. We're in genuine code, and we can test it in a lot of the same ways. So we can start looking at how do we break up our infrastructure as code projects into smaller chunks where we can test specific features and functionalities within that before we even generate the CloudFormation to push into AWS. So what can I do with unit testing? First of all, I can catch defects really early in the process. Right, so if I start putting business logic and things that I'm interested in validating into those unit tests, typically speaking, I can pick them up in a CI build and have that test fail and give me really rapid feedback to the developer, meaning I don't need to wait for it to deploy into the dev environment before I figure out that I've broken something. Next, it gives me a repeatable mechanism to ensure quality. Right, one of the great things about unit tests is that they are completely automated and I can run them rapidly and on demand or as I'm making changes to my code and again, get that rapid feedback. And it helps me avoid accidental regressions. So once I fix a bug that I found in my infrastructure as code, I can write a unit test to make sure that I don't accidentally bring that back into my code base. So what are some of the things that unit testing doesn't do? First of all, it doesn't ensure that my code will have 0 errors. It does ensure that my code won't have the errors that I specifically test for. Right, so just because you've got some unit tests doesn't mean that you are set to never have errors in your code. It also doesn't let you skip integration testing. I've heard people give me the argument of, we have thousands of unit tests that test every possible combination of path through my code. I don't need to bother with integration testing because I know that I'll pick up a bug there. The reality is that I won't know what code is going to run like in the production environment until I run it in the production environment or something that is a copy of. So integration testing is still a thing you should do. And last, unit testing isn't going to validate external functions and dependencies. So you'll often hear people talking about strategies like mocking for external dependencies. If you've written code against like the AWS SDK, for example, chances are that you have probably done that in a unit test at some point. So again, unit testing, not something that's going to help you with external dependencies. So why does all this apply to infrastructure as code? Now, first of all, catching bugs early, like I said, is a really good thing. I can catch them before it gets anywhere near an actual deployment into an AWS environment. So if I've made a typo on something like I've accidentally put some more RAM on my Lambda function, I'm probably not going to lose too much sleep over that. But if someone's made a mistake that wasn't caught in a unit test that, say, opens up some permissions that shouldn't be opened up, that's absolutely something I want to catch, even in a dev environment. So using unit tests can help me make sure that standards are held high inside of my code before I get anywhere near a real environment. They can also help me with specific policies. So I'm going to show you an example in a demo later about how I can make sure that I don't include IAM permissions that will escalate permissions. So like creating new users or attaching new permissions. I want to make sure that my CDK apps don't have those. So I can use these kinds of tests to make sure that my security standards and any other policies that I might have in my organization are being adequately applied to my applications. And lastly, it's really a great way to specify my requirements as code. A unit test is just a description of the specific requirements and attributes that I should be using in working with my applications. So the reality of all this, though, is the reason I want to capture all this in unit tests and to be able to run them really frequently is we're moving to a world where I'm going to be doing far fewer big bang releases. I'm going to be doing lots of really small incremental releases. If you look at, for example, how we do things in Amazon.com, you see hundreds of releases a day take place in there. So testing and automation is a really key part of that. So if I'm doing really small incremental changes, I want to make sure that every change meets my testing standards and that I can catch any of those issues at every single commit. So unit testing in the CDK specifically. Now, if you've been following the CDK since the very beginning, you will have noticed that there was an initial way to do unit testing if you were writing TypeScript or JavaScript projects. And this was through a library called Cdk Assert. So this essentially had a dependency on Jest as a framework, which is a JavaScript testing framework. And if you were, like me, someone who uses TypeScript, chances are you had a really good time with this. However, our customers like to use lots of different languages when modeling their CDK applications. Python or Java or Go, even C#. So having a consistent approach to testing across all of these languages was something that the team needed to get together. And so this came to the creation of a more recent module called Cdk Assertions. So this doesn't have that same dependency that links it to JavaScript. In fact, it's built using the same JSII framework that the entire CDK is built on, which means that as we add support for new types of tests in one language, all languages will benefit. So this module is still experimental. To be fair, so is the Assert one. So these basically just means that it is subject to change as we finalize the specifics of what the methods and properties and objects will look like through there. That doesn't mean that you can't or shouldn't use it. It just means that you might find that before we get to a point that we call it stable, that there may be some changes that are breaking. Now, as far as this talk is concerned, I'm not going to focus on the Assert module. Conceptually, a lot of the things that I'm going to talk through are still the same, but they're implemented slightly differently. So if you are going to go and start testing today, use the Assertions library. Now, within the Assertions library, there are 3 different types of unit tests that we have. We have snapshot tests, we have fine-grained assertion tests, and we have validation tests. So let's unpack what each of those are. So a snapshot test is designed to take the synthesized output of a chunk of CDK. So this is where I go from CDK code to CloudFormation. And I'm going to take that CloudFormation that has been outputted, the synthesized output, and compare it to something that I generated earlier. So this generated earlier piece is called a snapshot. So it lives in your source code as a .snap file. It's essentially just an export of the object structure that was generated by the CDK. But essentially, it'll just play spot the difference with that and tell you if the snapshot matches or not. And if there's a delta, it'll show you which lines are different and what text was different in each one. So I say use these sparingly because their mileage varies depending on how you use it. Let me give you a couple of examples. So let's say I am generating an actual CloudFormation stack for my application. Now, if I'm making changes every time I open up my IDE, make some changes, commit, make some changes, commit, I'm just going to be changing that snapshot with every single commit because I'm going to be changing the infrastructure. So really, in that context, the snapshot's just validating that I remembered to update the snapshot with every commit, and if I didn't, the test will fail. So less value out of something like that. However, if I look at a model where I'm writing something like reusable constructs, where other people are going to consume my construct and I'm not writing an end stack, and I want to make sure that if I provide a specific set of input properties, the output CloudFormation looks a specific way. That's a really great use case for snapshots. So think about what you're getting out of using snapshots as a testing strategy. Use them sparingly, but definitely use them. Now, this is where you'll spend most of your time in writing unit tests for the CDK. This is the fine-grained assertion tests. So this essentially lets me say, check the properties of specific resources that have been outputted. So again, we're dealing with that output of the CDK process. And make sure that specific properties either match or are like or are not like specific patterns that I want to provide in my tests. So I tell people here that testing every single attribute is not necessarily going to yield me the best results for ultimately the same reasons as why you don't test with snapshots for a full stack, because you're just going to be changing the properties in the test on every single commit. But I do want to test things like key business requirements. I want to test where I've got dependencies coming in and out of my system to make sure that I'm not breaking something where either I depend on somebody else or they depend on me. Or properties that are going to be dependent on within my stack. So think about it, I might put a test in that says I want to make sure that all of my S3 buckets have encryption on them. That's a really good test to put in there. I don't necessarily need to do it bucket by bucket, but I can have a good test that'll catch all of those things. The other bit of advice I give here is look at validating a single thing in each test, as opposed to just writing one test that validates a chunk of properties. For example, validate that my S3 bucket has matching properties, and it checks like 10 different things. If I break one of those, I'll see that the test failed, but I'll have to go and do some figuring out to understand exactly what property I broke and how I broke it. Whereas if I have a test that says check S3 bucket encryption, check S3 auto delete, check S3 name, if I break one of those, it's very specific in the name of the test. So I can very clearly know what I've broken and go and fix it. So just a little bit of a way to structure your tests and think about the intent of what a test is telling you when it passes or fails. The The last one I want to talk about is validation tests. So again, these are really useful in the sort of space of custom constructs, where I'm going to be exposing property interfaces and things to other CDK constructs. So I can test for success based on specific inputs and whether or not I get an output, or test for validation on my inputs to throw exceptions that are meaningful. Again, I'll show you some examples of those in a demo that we're going to do right now. All right, let's go in here. I'll zoom that up a touch. All right, so here's a couple of examples of some CDK unit tests. So I'm working in TypeScript. If you're using one of the other languages in the CDK, the property methods and names are all going to be exactly the same. What's going to be different is the syntax, like where the curly braces and semicolons are. So you could probably follow along and get the gist of where we're going with this. So my first test here tests that I match a specific snapshot. So what I'm doing in each test is I'm setting up a CDK app, I'm creating my stack, and in this case, once I've got a stack, I'm adding demo function, which is one of my constructs that I've created. And what I'm going to do with that is synthesize the output. So here I can call app.synth and programmatically get to the actual CloudFormation template that was generated when it was synthesized. So normally when you do this at the command line, you type cdk synth, this all ends up in the cdk.out directory in your folder structure. Here, I can just grab it in memory as a variable and then refer to it in my tests. Now, what I'm doing here is I'm leveraging, so Jest is still my testing framework within JavaScript, to say I want to expect a certain value to match snapshot. So that tells Jest I'm doing a snapshot test. Now, in terms of how I handle this template, there's a couple of things to be aware of here, and I want to just highlight why I'm doing it this way. So I'm saying template.fromJSON. Now, because I've synthesized the template out to JSON, I can go and pass that in here and start doing tests on it. So there's two things I want to talk to here. One, this means I could write CDK-style unit tests for literally anything that I can drag in as a JSON object, i.e. a JSON CloudFormation template, or a YAML CloudFormation template that I can programmatically pass as JSON. So you can write unit tests on things that are not necessarily CDK-based, worth keeping in mind. The second thing is that the template object here has a from-stack method, and those of you who have played around with the unit tests might be saying, but Brian, why are you not using that? That would be less code, and you are correct. The thing here is that I'm currently working in a mix of CDK versions. So again, for those who have been playing around with the CDK, you might have seen that we have Cdk 2.0 in a release candidate at the moment. That release candidate does not have the Assertions module in it yet. So because I'm using the Assertions module from Cdk 1 and everything else from Cdk 2, that means I've got to go out to a JSON object and then go back to doing that in memory. So, but in reality, once we get to the release of Cdk 2, you'll see that I can just go from stack and I'll pass in my actual stack object. Now, this particular test, so let's go in and have a look at my directory here. You can see that there's a folder here called _snapshots . And inside of that is a .snap file. So this is what I talked about in terms of that automatically generated snapshot. So what's going to happen here is as long as everything in that test matches what's in that file, then I'll get a pass on that test. So you can sort of get a feel for why that's useful in the case of a custom construct. Let's move on now to the fine-grained assertions. So here I'm writing a test that says I want to include a Lambda function somewhere in my output, just as a really generic example. Again, I do the same style of setup where I synthesize my test and get my template. And here I'm now moving into another method called Assert Resource. So what this one is going to do for me is look through that output for a CloudFormation resource, in this case, AWS Lambda function, and it's going to check the properties of that match what is defined here. So in this case, it's going to have a top-level object called properties, as all CloudFormation resources do. And it should have a handler property with index.handler as the value. Now, again, there's a shortcut method here if you don't want to put that properties on one at the top. I could say has resource properties and just nest that. I've deliberately left that there to be able to show that you've got a couple of options. But it's useful that we have this top level has resource, because if I want to test things that aren't in the properties, like tags or metadata, for example, I can still use tests to validate that they have been generated correctly. Now, the last one here is around how we want to go about testing validation tests of custom constructs. So let me show you my custom construct really quickly so you can see the thing I'm looking to validate. So here I've got my demo function class, which is a CDK construct. And within it, I've got a little bit of code here that just says there's a property called timeout, and I want to make sure that the value that's supplied there is under 300 seconds. Which is a completely arbitrary requirement, but serves my purposes for showing you what this kind of test does. So what my test here is going to do is I'm actually testing for both a positive and a negative result. So accepts a timeout value that's under 5 minutes. So I create my demo stack and specifically specify a duration that's under 5 minutes. Now, next, I go through and do one that says 10 minutes. Now, you'll notice in the first test, I'm expecting it not to throw. Right, so I want it to run cleanly and not have any exceptions. That's my expectation of that test. So I'm not testing specific CloudFormation output here. I'm testing my ability to create those resources and run that code in the first place. So this will happen during synthesis. So again, a really good thing for custom constructs, less so something that you'll use in the final output of CloudFormation. But this second one, I am expecting it to throw, and I'm specifying the very specific error message that I'm expecting to see here. Because in theory, this could break for any number of reasons. I'm expecting it to break in a very particular way here. So I can do that style of testing for my custom constructs to make sure that business rules and validation is working correctly. So those are 3 types of tests we can do with the CDK. If anyone's got any questions, I do have the chat window open in front of me here, so feel free to drop stuff in the chat and we'll answer them as we go. All right, so I want to get into a little bit now about how we build CDK applications for testability. So the concept of building for testability has been around for a while in terms of how we write unit tests for code. You know, we will restructure code to make it easier to test because that gives me less technical debt overall, because I can have this validation built in, do it in unit tests, all good things. So I want to use this section to talk through some anti-patterns of things that I see in CDK apps that I see in the wild, and I'll put my hand up. I've written a few like this as well. But I want to highlight why they don't necessarily work for good unit testing. So the first one, and I have this conversation a lot, is how do I structure my CDK project? You know, now that I've got the ability to pull things out and put them in different files, and I can have constructs inside of constructs and stacks with constructs there, how do I go about structuring this in a way that helps me write better unit tests? So one of the things you will find very early on is that just putting everything into that first file that gets generated when you create a new CDK project under the lib directory there, that's not going to be super testable. It's also not going to be super maintainable because you'll just have this one monstrously large file that is going to be hard to follow. You'll be scrolling up and down and it's not a great experience. So my advice here is to go and use custom classes or functions to pass things around to separate your logic out into individual pieces that you can run independently. Right, so I might have a top level class that represents my stack, and from there I'm going to call out to child constructs. So I'll have child construct 1, 2, and 3. I should be able to write unit tests against each of those constructs independently. So I don't need to synthesize the entire stack to test child construct 1. I can synthesize just its outputs, and then I know that when I'm running tests against particular CloudFormation resource types and looking for specific properties, that it has to have come from that resource. So that gives me a really nice way to break it up and focus my tests against individual chunks of my modeled infrastructure. Question in the chat, will snapshot testing also help when updating the CDK version of your project? What are your thoughts on it? Yes, actually. So one of the reasons I would put a snapshot test in temporarily is usually around things like refactoring of a CDK project, where I want to make sure I don't accidentally create a destructive change in CloudFormation. Or If there is potentially some reason that I'm worried about a breaking change in a version upgrade of the CDK, then yeah, there's an argument for that. Typically speaking, that's not something I've seen a lot of, and you'll see less of it going into CDK 2.0. So if you go and look up, there's some notes that talk to changes in CDK 2 from CDK 1. And one of the things we talk about is how we're treating stable resources versus experimental ones. And that we essentially are separating the experimental ones out into separate classes and objects that aren't brought in by default. So what this means is we will be able to be very specific about these stable resources, and in the tests that we have within the CDK itself to make sure that we're generating good code that's not going to break everybody else's code, we catch that sort of stuff there. So if you want to go and do that kind of testing yourself, yes, you can. Is it something that I would recommend specifically? Probably not for everyone, but your use case may vary. And JJ's just dropped the changes in CDK2 link into the chat. Cool. So the next one I want to talk to you about is, again, another slight paradigm shift in how we do things with the CDK. And specifically, this is around how we pass configuration into our CloudFormation templates. So in the old days, when we wrote native CloudFormation, typically speaking, I would write a single CloudFormation template and I would make use of parameters in that template. So that if I deployed it into my dev environment, at deploy time, I would specify those values and CloudFormation would go and do it. And then I would go and deploy to test. And at deploy time, I would specify different values that were relevant to the test environment, and we would go then. Now, the main reason for that is keeping separate templates, the individual template files. If I was doing that, I would have one for dev, one for test, and one for prod and any other environments that I had. And every time I needed to make a change, I would then be making a change in 3 different places. So this was not exactly easy to maintain, right? Now with the CDK, what I can do is I can generate hard-coded values for each environment because I only need to write the code once, but I can synthesize it with multiple sets of configuration at synthesis time. So the example here is how the Cdk Pipelines module works. This is exactly what we do when we start talking about how we deploy to multiple environments from code pipeline. So you'll end up with specific templates that target each of those environments. Now they came from the same build and the same commit, but it's not a single CloudFormation template anymore. Now this simplifies deploy time because I don't need to worry about how I draw parameters in at deploy time in any given environment. It also means I don't need to worry about did those values change from when I did my build to when I do my release. I know that they are captured at the point in time when I generate that template, and that version that I release will have those exact values in it. So that's a really good pattern to get into with the CDK. Now, from a testing perspective though, I want to make sure that I'm testing all the possible input combinations. So if I have, let's say for example, deploying a CloudFront distribution in my Cdk app, I'm probably going to have a custom domain name in there somewhere. I might have some additional settings that go with other things in my application as well. Now I'll have a different domain name for dev, test, and prod. So there's going to be a couple of different configurations that I'm going to pass into my code. So I want to write tests that will validate that all of those will actually synthesize in a really valid way. If I, for example, don't test the production ones, but just test the dev ones, it'll pass a unit test because the dev one might be valid, but I've made a bug in the production one. So you want to make sure that all inputs are going to be tested in the same way. So the next thing that comes up is around dependency management. So back to the first example where I said we should break everything up into different constructs. That's going to lead to scenarios where something in construct 1 needs to be passed to construct 2. And in the diagram I've got at the bottom here, assume it's an S3 bucket. So child construct 1 creates an S3 bucket, and the second construct needs to consume that bucket as an input. So this all works really well in the CDK. The code's clean and easy to write. But what I want to do with my unit tests is I don't necessarily want to depend specifically on child construct 1. Again, let me give you a hypothetical scenario here to explain why. If I create some sort of bug in child construct 1 where that S3 bucket doesn't look the way it should, I've screwed up a property, or maybe I've taken the bucket out completely, I'm going to see a bunch of test failures in both child construct 1 and child construct 2, and then I'm going to need to try to figure out where do I start to figure that out. Whereas if I take the approach of saying, well, child construct 2 needs an S3 bucket, and that should have a couple of properties on it based on what it needs. I can actually just create one of those in my unit tests, so I don't need to rely on child construct 1 in any way, shape or form. So this way, if child construct 2 is failing its tests, I know it's because it's failed on something within itself and not an external dependency. So you want to avoid in your unit testing having situations where you're creating dependencies between those individual units of source code. Right, think back to that definition of unit testing at the start. We want to test things in isolation. The next bit of advice I give is make running tests really easy to do. Because if it's not, chances are people won't run tests and you will probably just break builds anyway. My standard advice here is integrate it into the process in as many points as it makes sense to do. So the first low-hanging fruit, put an extension into your IDE that can run unit tests. So I use Visual Studio Code. The Test Explorer in VS Code is a really great way to visualize those tests. It also gives me the ability to attach a debugger, and I can debug my unit tests directly in the IDE. Again, super important if I'm getting weird results and I can't understand why. Use a watcher and do it in the background. Again, those extensions in a lot of cases will do that for you. There'll be a setting that just says run whenever you see a code change. Great, and we'll go and do that. You can do things like git commit hooks. So before I allow code to be committed, run the tests, and if there's a failure in the tests, don't let git commit the code. Now, again, developers can bypass that, so don't make that the only thing you rely on, but it's another easy way to make sure that tests are going to run before code is committed and pushed through to your pipelines. And in the same sort of vein, make looking at the test results really easy to do. So one of the things that we've got support for in AWS Code Build is around visualizing different types of test results. So essentially, as long as you can generate those test results in there's about half a dozen different formats of XML, and they're usually things like NUnit, JUnit, really common standards for unit test results. Code Build will be able to take that test output and visualize it in something like the screenshot here. So you can see in this particular one that I ran a couple of days ago, all of my tests were passing. Yay, great success. But if they were failing, it's really easy for me to just drill down in this visual report to figure out what failed and why. If you've ever looked at something like Code Build where you've had to scroll through your logs to figure out why there was a test failure, you'll have a level of appreciation for this specific feature. So before we flick back into demo, I want to introduce you to a few of the different types of tests we can do, and then I'm going to go back and show you how some of these work and how the whole thing comes together. So in the Assertions module, there is a class called Match. And the Match class has a few different helpers that will let us do different types of validations based on the type of thing you want to test. There is object like, which is where we start looking for a superset of a pattern. There's an object equals, where we look for a deeper quality of objects. There is an absent property, which says make sure that this value doesn't exist. And there's array with, which is where I say there's going to be an array of objects and they need to match at least this subset. So let me unpack those with a few examples so you can get a feel for what each one does. Now, match.objectLike is going to target a superset of a provided pattern. Right? So this is essentially a way of saying make sure that these properties are on the object, but it can have other properties as well, but it has to have at least these ones. So again, this is really common in those fine-grained assertions where I might be testing for a specific property in an individual unit test. So checking the encryption status of a Dynamodb table as an example. So in the code that's on the left here, and this comes directly from the Cdk documentation, words like wobble and flob are not my personal preference, but here we are. So you can see, if I write a test like the one in the green box, I'm looking for a resource of type foobar, and it needs to have a property called Fred, which matches an object like this. Wobble, flob. So that would pass because you can see that in the code on the left, that's exactly what I've got. But if you look at the one at the bottom, I'm saying match object like brew coffee. Now the property brew isn't even there, let alone matching the correct value. So that's going to give me a failure. I don't care about the rest of the properties. I just care that the thing that I'm asking for is there and that the property value matches. Now, object equals is a way of saying make sure that this is an exact match of these properties as opposed to a superset. So in this particular case, the top result using the same input says look for wobble, flob, bob, and cat. Now, that's exactly what's in the template, so the top one passes. The one on the bottom, however, it has that wobble property, but it's missing the bob property beneath it. So this one's going to fail because it's not an exact match of all of those properties. So there are scenarios where this makes a lot of sense and you need to do a check of every attribute to ensure a specific output. Now, absent property is a really good way to have a look at making sure that a specific property doesn't exist in your cloud formation. And there are a bunch of scenarios where you might want to do this, and I'll show you one in the demo. So in the one at the top, I'm saying that the property brew should be an absent property. In the case of the input on the left there, it's not there. So that would pass because brew doesn't exist. However, when I change that and test for wobble, you can see that that property does exist. So that test would fail. And lastly, the array with. So I've tweaked the input slightly for this example. So the property Fred is now an array of strings with wobble and bob inside of it. Now, when I say match array with, I'm not matching the entire array. I'm just saying make sure that these specific objects are in it. So wobble, being the one thing I'm asking for in the top test, is in that array. So that would pass. Cat, however, is not, and that one would fail. So with those combinations of things in mind, I would like to plant the seed of a couple of different ways we can use these. And testing for the absence of things is a really important one to highlight. So I touched earlier on the example where I'm going to have a set of IAM permissions that I want to make sure don't exist anywhere in my template. All right, I want to make sure there are no IAM policies where there are things like IAM create user or IAM attach policy, because these are things that allow for permission mutation, for escalation of permissions. So I could write a unit test that says, if you see any of these in the code, fail the test and go back to the drawing board because something's gone on that shouldn't have, because that should never be in my template. So that's one really good example, and I'll show you what that looks like in code in a second, like right now. All right, so we're in a slightly different project here. So this one's a little bit more robust. It's a little less hello worldy. So this particular CDK one I'm dealing with deploys a serverless application. So I have a JavaScript page that sits in behind CloudFront in S3. I have an API gateway that calls a Lambda function, and there's a bunch of things around that, like some CloudWatch synthetics for monitoring. There's a WAF in there. There's code deploy for blue-green deployments. A lot of different moving parts, lots of things to write tests on. So in my tests here, so you can see I'm starting to do a couple of things here that are slightly different to the previous example. So here I create a describe block and I say I'm going to test my REST API. Now you'll notice in this case I'm creating my CDK app and my stack at the very top. And in this case I'm asserting that I've got my template, and I'm going to go through and be able to use that in my tests. I'm not recreating it in each individual test. Now, in this particular case, I know that that's okay because A, this is a bit of demo code, and B, I'm not actually making any changes to that assert object at any point through these tests. Something to be aware of is where you are going to reuse these, that if there's a chance your code is modifying it, you could be potentially poisoning that object from one test to the next, which might lead to a false positive or a negative that should have been flagged the other way around. So just be mindful of that sort of thing. Now, in here, though, you can see there's a couple of different things I'm doing that I didn't call out in the slides. Things like counting the resource count, right? So how many REST APIs did I generate in here? It should be 1, not 0, not 2, just 1. I'm going through and checking things like make sure that there's a code deploy that's going to deploy my Lambda code. Okay, great. That testing for a single thing in a unit test. If that fails, I know exactly where I need to go to fix it. You can go through and go iterate through the results and start testing individual things. So here's an example where I'm using the find resources method to say, get me every code deploy deployment group that's in this template. Then iterate through those and make sure that every single one of them has at least one CloudWatch alarm. So this says don't allow any code deploy that is deploying code to run without an alarm for an automatic rollback. So again, another really useful check there to make sure that we're doing good practices with code deploy. Some other ones that I want to run through, making sure that your stacks synthesize in full. So here you can see I'm creating my new stack, and I'm expecting that to not throw any exceptions. And then I'm synthesizing it, and I'm also expecting that to not throw any exceptions. This, again, a good practice to get into because I could be testing all of the individual parts of my stack. I want to make sure that they do actually work when I pull them all together as well. Now, another couple of interesting ones here. So this is an example of that injecting a fake dependency. So I've got a class here called synthetics. It's designed to run my CloudWatch synthetics monitoring, which is going to test my API every 60 seconds and make sure that it's doing the things it should do. Now, as part of that, I need to pass an API gateway into that object. Now, in reality, when I run this and synthesize my actual CloudFormation output, that's going to come from the REST API class. But in this particular case, I've just created a very, very simple mock API because I know all I need is the ID of the API gateway to get the URL. I don't actually need it to do anything functional. I just need that object. So I can create myself just a mock one here very quickly, and I pass that into my synthetics class. So this is how I can know that if there's a failure here, it's because of the synthetics class, not because I've done something different with the API gateway. Now, other than that, I go through and do a lot of the same kinds of tests, but there's an option here where I'm using match.absent. So one of the things you can do with a canary is attach it to a VPC. Really useful if you're testing things that are going to be internal and private, as opposed to things that are facing the public internet. Now, in my case, my API gateway is facing the public internet. So I want to make sure it's accessible that way, and I should not be running my canary in a VPC. So in this case, I'm saying make sure that VPC config isn't on that object. So that's a way that we can use match.absent. Match.arraywith. So here's an example. If I've got an S3 bucket, and that S3 bucket, I'm expecting to have specific lifecycle policies. Now, I might have 3, 4, 5, maybe more lifecycle policies that map to different path prefixes and different specific things that they should be doing. Now, I don't necessarily want to say just test that the lifecycle properties look like X, because if I get one of them wrong, I need to go figure out which one I got wrong. Testing them individually makes more sense. And so for that, we can test with the ArrayWith function, in which case I'm looking inside of my lifecycle configuration for an object that has expiration in day 7 and is enabled. So if it sees that in the array, that test will pass. Now, if we go into the front end test here, we've got ways of combining some of these. So I've talked about them all independently, but we can start nesting them where it makes sense to do so. So in this case, I've got a CloudFront distribution and I want to test for a specific cache behavior. So again, I can have multiple cache behaviors, and those cache behaviors can actually have quite a lot of properties on them. And so having to put them in full into a unit test is not necessarily practical in terms of validating that only one specific property that I care about is there. So in this case, I'm saying the cache behaviors should be an array with, and it should be an object that is like, as opposed to a deep match, and I specify the properties that I want to specify. So nesting and using these in combination lets me get very particular about what I'm looking for inside of my CloudFormation. And the last one I wanted to show you here before we start running a few of these, and we'll break a couple of them, is that IAM security one. So here is an array where I have a list of permissions that I don't want to exist in my stack. Right? I don't want any of my IAM policies to include things like create role, change password, remove user from group. These are all potentially bad from a security standpoint. So in this case, I can do wonderful things like a for each loop. Can't do that in CloudFormation. But I'm going to iterate through that list of permissions, and I'm going to test by saying, look for IAM policies where there's a match of that particular permission, so looping through each of those individually. And I'm going to check that there are 0 of them. So I can validate that there is nothing in there that matches that pattern. Right? So if there is something that is matched, that'll give me the count of how many of them match that, and it'll fail that test for me. So this gives me a mechanism to be able to take those tests and fail them out. Now, again, the syntax from Jest is not there completely. In Jest natively, I would just go .not and test for that same match. So that isn't implemented there yet. There are some not matches within the assertions library, but I couldn't quite figure out a syntax that would work cleanly with this particular test type. So instead, I'm testing that count as a way of validating it. So let's say I've got all these tests and I want to start running them in my IDE so I can know whether or not they're going to work for me. Now, the easiest way to do that is I can just, command line, run npm test. So again, you'll have a different command if you are working with a different language, but the basic concept is the same. You'll have some sort of command that runs your tests. So this typically takes about 12 seconds. As you can see, all of my tests have passed. Great success. Let's go and break something. So one of the things that I've baked into my REST API, no, that's the WAF, wrong file. In the REST API, I have left a convenient line here that if I uncomment, you can see adds IAM create user. So this is definitely something I do not want in my stack. So if I do a quick build and run my tests again, this should go through and complain saying, hey, you've put a permission in there that probably shouldn't be there. Let's go back and have a think about our live. So within the next 12 seconds, we will see, one failed, excellent. And so in this case, I can see that it's failed because there's an IAM create user in there, expected 0, received 1, go back and have a look at the changes you've made. So that's kind of cool. Now, if you're like me and you're super comfortable to command line, this is probably not a bad way to operate. However, I accept that there are plenty of people who aren't necessarily as comfortable in command lines, and so working in an IDE means not having to live in a command line. So in this particular case in VS Code, I've got the Test Explorer extension installed and the Jest extension installed there, which lets me bring my test results in. And I could literally go in here and just press this big old play button at the top. And it's now going to go through and do exactly what I just did at the command line, but it's going to pass those results out and give them to me in a really easy to interpret tree that I can drill down within and get some context about what's breaking and where. So in this case, you can see that that security test I just broke failed, and I can see the specific output if I double click on it. Now, let's say that that wasn't enough for me to figure out exactly what was going on and I needed to dive into that further. I've got the ability to go through and attach a debugger. So here I can see that that's the one that's failed. It's highlighted in red for me in the IDE, which again, really super useful. So I'm going to put my breakpoint in here. And now I can click this little context link for debug, and it's going to do the same thing. It's going to spin up Jest to run just that test suite, and it's going to attach the Visual Studio Code debugger to it. So I can interrogate what's going on in that test in my IDE here and figure out why on earth is that breaking. So excellent, there's my breakpoint. I can see the assert object, which is my template, and have a look at all of the resources that are in it and start pulling that apart to figure out what's going on. I can do all my usual debugging things like stepping over, stepping into, and progressing through that code, add watch variables, etc. It's just standard JavaScript debugging, and you can do this with any of the other CDK languages. So I'm going to stop that one and stop my debugger from running. So I'll go back and comment that back out, and we're good. All right. So that's sort of the end of the demo that I wanted to run through. So let's have a bit of a recap of things that we went through. And again, if you've got any questions, more than happy to sort of run through them as well. So we talked about what is unit testing and why do we care. We talked about unit testing for the CDK specifically and the 2 different libraries that exist and the fact that you should be using assertions. We talked about building infrastructure for testability and considerations that you should make when structuring your CDK applications to make them more easily testable. I showed you that we can view those results and we can do that in code build or we can do it in an IDE using different tools. And I talked about the different methods and helpers that exist on that match class for being able to help us write these really effective unit tests for our CDK code. So a couple of other considerations before I wrap up. First of all, code coverage reporting in CDK applications is basically useless. So in normal unit testing, code coverage is a metric that a lot of test suites will cover and report for you on how many lines of your code were executed in any one test. So this gives me a good idea of the percentage of my code that a test path is passing through. So if I've got low code coverage, that means I've probably got a lot of code that isn't being touched by a test, and maybe I should go and evaluate that. Now, think back to the scenario that I showed you where I tested that the entire stack synthesizes and creates correctly. At that point, it is running 100% of the lines in my stack, meaning that even though I've not tested individual properties in every single thing, I'm going to get a code coverage number that's going to be very close to 100%. So typically speaking, I say don't bother with code coverage reporting for your CDK projects. Absolutely still look at it for every other bit of code you're writing, but just understand that it's not something that brings a lot of value to a CDK application. And I touched on this before, but just to highlight again, be very careful reusing objects like I did in that demo between tests. Now, yes, it'll run faster, and that might be important if you've got hundreds of tests. I've got a couple of CDK projects where it will take a good couple of minutes to execute all the tests, so that's a thing. But just be very mindful of when you do it about potential risk of poisoning that object from one test to the next. If all I'm doing is just checking a match on those properties, it's probably fine, but be very mindful when you do it. So my next steps to you, my call for action. You've been hanging out listening to my dulcet tones for the last 45 minutes, so let's see what's stuck. Ask number one, stop deleting that test folder. When you create a new CDK project, there is a test folder there in every language framework ready to start writing unit tests in. I see a lot of people say, we don't need testing, and just delete it so that it's not there. Stop deleting it. Start writing some tests. It's a really good idea. Ask number two, next time you fix a bug, write a unit test for that bug. Now, this is actually a really good way to go about starting with how you want to write unit tests if you've got a very large code base and you don't know where to begin. Typically speaking, if I focus on areas where I'm fixing bugs or adding new functionalities, I'm going to cover all the hotspots of my code just by nature of where I'm working. So if I just start adding tests for the things that I'm doing and the things that I'm changing, that's a really, really great place to start incrementally building out my tests and getting coverage where it matters. Now, at some point, I'm probably going to want to spend some time in a sprint where I go and catch up everything else. But if you don't want to put time aside to just write tests to get you caught up on what you should have, just focus on writing tests for the things that you're changing. Ask number three, put an IDE in and put an extension in that will let you view those test results. Again, your specific combination of IDE and language will vary, but you'll get basically the same kind of functions that I showed you out of most common test plugins in most IDEs. And last but certainly not least, put these in your pipelines. Right? If I've got a CI/CD pipeline that's doing a build and release of my code, it should also be doing a test to validate that I've not broken things. Question, what is the name of the VS Code add-in for testing and debugging CDK tests? So it's actually not CDK specific, it's just Jest. So if I look at my extensions here, the ones that you want. So the Jest Test Explorer, and I think the other one is just called Test Explorer. Test Explorer UI. So those are the two there, and that will drag in the test adapter converter from memory. You don't need to install that on your own, but if not, that's there as well. But those are the ones that will give you those visualizations of the test results, and that works for anything that's Jest related. If you're using a different language like Python, for example, I have no idea what the extensions are for those, but they exist, I'm sure. But those are the ones that will work for Jest, for JavaScript and TypeScript. Cool. So on that note, thank you for watching and hanging out with us. I'm going to hand back to JJ, but we'll be loitering around in the chat for a little while. So if you've got questions or anything you want to discuss further, we'll hang about there. But otherwise, I'm going to hand back to JJ to wrap up for the evening.
Thanks, Brian. Great talk, really, really interesting. Thank you. So as usual, everyone, let us know what you'd like to hear. Please get in touch. Let us know the sort of content you'd like us to dive deep on, like CDK or any other areas. We've got a plethora of resources available to us, so let us know what it is you'd like to know about. And please submit your feedback in Meetup. We read each and every one of them every month. Please let us know what you'd like to see, as I said, how we can get better, what you'd like to do differently. We do know you want to meet up in person. We will do it as soon as we can, we promise. So please If you enjoyed what you saw tonight, tell your friends. Friends don't let friends miss the AWS Canberra user group. We will continue to be online, so your friends, if they happen to be interstate or international, are also welcome to join us live here on Twitch. And with that, that's basically us for the evening. So thank you very much. This is actually our last one for the year. I hope you really, really enjoy your reInvent. You have a happy and safe end of the year. And Brian and I will be back early next year in February. So yeah, really look forward to seeing you all. Hopefully we can get back in person by then. But yes, thank you everybody. Have a great night and thanks for tuning in.